Hi everyone, this video is for section 7.3, double angle identities, and speaking of double and identities, we're going to prove not one, but two identities. I have the first one outlined in green, and I have the second one outlined in pink. So to begin, whenever you're asked to prove an identity, you want to actually take a look and see where you have the most opportunity to use the identities that you know that you have in your arsenal. So for example, with the first one in green, tangent of 2x is equal to 2 times the sine of x times the cosine of x all over 2 times the cosine squared of x minus 1. I really don't know much about tangent from the identities that we have, but take a look at the right-hand side. I think that's where we're going to have the most success. Specifically, take a look at the numerator, and I went ahead and I included the double angle identities from our text. Notice that the numerator looks remarkably like the right-hand side of the identity for the double angle for sine. Also notice that the denominator looks amazingly similar to the right-hand side of one of the double angle identities for cosine. So I'm just going to go ahead and rewrite that, all right? So I know that the numerator is going to be the same thing as sine of 2 times x, and that's all going to be over the cosine of 2x. And lo and behold, we know what our definition of the ratio for sine over cosine is. We're going to get the tangent of 2x. Yay, we made it. So let's go ahead and scoot this one over a bit. Hopefully you have, well, here, I'll leave it so that we can see those two identities. Okay, so again, our issue with this problem is, where do I start? Which side is going to give me the most help? So I'm kind of noticing again that I do have some double angles that are being explicit. So I'm going to start here, and my goal is to get the solution from my manipulations. So in this case, we'll go ahead and we will write it in purple so that it'll pop up. We'll have 1 plus, and we'll say cosine of 2 theta. We need to be careful here in terms of what choice to pick. We want it so that the denominator of our final outcome is going to be 2 times the sine of t minus 1. So to kind of move things along a bit, I'm going to choose to use 2 times the cosine squared of t minus 1. So I'm opting to use this identity again. If you didn't realize to use that initially, it's okay. You probably will have to do this a couple of times. But again, just for the sake of the video and just so that you don't have to watch me make mistakes repeatedly, I went ahead and went with the correct approach. The nice thing is that with the sine of 2t, I know that that's just going to be equal to 2 times the sine of t times the cosine of t. And then we're going to do minus cosine of t. Oops, I'll write it in a different color. So I'm going to rewrite that minus cosine t that I have above. So minus the cosine of t. So notice what happens. Notice that I have a positive 1 and a negative 1. So that's just going to leave me with 2 times the cosine squared of t. Also notice I have a cosine in the first term, and I have a cosine in the second term. So that means that I can factor out a cosine of t, and that's going to leave me with 2 times the sine of t minus 1. Do we notice that we're starting to get to where we need to be? So from here, I can reduce factors. So I have a factor of cosine up here, so I can get rid of one of those squares, and that will cancel with the 1 cosine down here. So this leaves me with 2 times the cosine of t all over 2 times the sine of t minus 1. And there you have it. We've proved it. I hope this video was helpful.